In this video, we're going to do subsection 1.4.3, where we're going to review the equations of conic sections. Knowing the equations of graphs of circles, ellipses, hyperbolas, and parabolas are going to be useful because they will eventually help us graph the quadric surfaces. That is the goal of this bigger section. So let's start by looking at the first graph here, and in blue we have the graph of a circle. And the equation of a circle centered at the origin is x squared plus y squared is equal to r squared. But what's really important about this equation is that the coefficients, here given as 1, of the x squared and the y squared are the same. So in general, if ever you come across an equation in the work that we will be doing where the coefficients of x squared and y squared are the same, then we know that we have a circle. Now, if those equations are not the same, if those coefficients are not the same, so if I've got ax squared plus by squared is equal to k, these things are all positive numbers again, but now I have a is not equal to b, then the object that we're looking at is an ellipse. And in high school, you may have been given the equation put in this form for an ellipse, and you may have learned about semi-axis and major axis and minor axis and that sort of thing, focal points. I'm not interested in that. We don't need that for the work that we'll be doing with quadric surfaces. We need to look at the coefficients, pay attention to whether the coefficients of x squared and y squared are the same or different in this equation to distinguish between ellipses and circles. Let's go ahead and look at the next graph where we have hyperbolas. And again, in high school, you may have been given this sort of equation for the hyperbolas in blue, y squared over b squared minus x squared over a squared is equal to 1. And for the hyperbolas sideward facing in red, x squared over a squared minus y squared over b squared is equal to 1. I'm not going to be fussy about that kind of equation. In fact, that probably will not come up much for us. What we will need is simply that the coefficients of x and y are opposite sign and different. So we might have ax squared minus by squared is equal to some number k, and we might have sort of by squared minus ax squared is equal to k. Again, if we take these coefficients, these numbers as positive numbers, we will have hyperbolas. We'll have hyperbolas when these coefficients, whether they're the same or different, have opposite sign. Then we'll be having graphs of hyperbolas on our quadric surfaces. Lastly, we have here parabolas. And again, the detail that you might have learned about focal points and directrix and that sort of thing in high school, not going to be of any importance to us here. What we care about is that the equation or the graph in blue has the x squared and the y not squared, and in red, the sideways facing has the x squared, the x to the first degree and the y squared, and in particular, we have one second degree variable and one first degree variable, and that will give us parabolas. So in the next video, we're going to use these equations of conic sections to help us graph the quadric surfaces, what we're really interested in.